and these charges on each atom, they interact with each other using Coulomb's law. You know Coulomb's law? You must be knowing this one. Just a minute, yeah. Coulomb's law. It's like if that one point is 1, Q1, Q1, this is R12. Yeah, I am sure you know this one, right? This one you know, this part. If there are two charges, how do they interact? They interact by Coulomb's law, because it is if the charges are Q1 and Q2 and there is a distance r, then it is Q1 into Q2 divided by R12, that is the Coulomb's law. So, in the non-bonded term, the electrostatics is governed by Coulomb's law. So, just to I will write it clearly. Okay. So, now we are talking about bonded term is over, we are talking about now non-bonded terms. Non-bonded terms, and non-bonded terms, the first is the electrostatics. Electrostatics, which is nothing but Coulomb's law. Only thing we have to this is J, this is R I J, I equals to 1 to n by 1 minus 1 and J equals to I plus 1 to n. And what is n? N is the total number of atoms. Okay. So, so a typical protein actually has many atoms, many means in the order of 1000. So, protein may have can have or more atoms. So, in this expression, which is E electrostatics, all possible atoms are interacting with each other. So, which means that atom number 1 is interacting with atom number 2, 1 with 3, 1 with 4, 1 with n, then 2 with 3, 2 with 4, 2 with n, right, all possible pairs. Because your system is has many atoms, maybe over thousands, and each atom has a charge, small charge, and they are interacting via Coulomb's law, and I have written after this summation. So, you have to take sum overall. This is the electrostatics part, and this is very easy. This is actually nothing but Coulomb's law, but only there are many particles. So, you have to do all combinations 1, 2, 1, 3, 1, 4 all. Okay. So, this is another okay, one non-bonded term. Okay. Okay. Now, I have a question for you. I will try to speak slowly. Let us say you have 2 atoms in a system as an example, just 2 atoms, these 2, and they do not have any charges, charges are 0, no charge. Will they interact? Interact means, is there any interaction between these 2? There is no charge. In other words, if so let us say they are very far, if they are very far, no interaction. Now, I am bringing them close, will the energy change? Okay, that you have to think. No, they do not have any charges, then they are very far. So, if I plot it, so when they are very far, this is energy and this is R, sorry, this is R. So, when they are very far, energy is 0, which means this is interaction energy, it is no interaction. Now, we are bringing the R, we are bringing them like this, right. So, we are bringing slowly close. Question is, will the energy change? If the energy changes, which means they are interacting with each other. This is the question, what do you think? But they do not have any charge, so they cannot interact by electrostatics. Any idea? So, how this plot would look like? Will it be just like this, or it will increase or decrease? That is the question. Yeah, let us say let us ignore this for the sake of discussion. It is just two atoms. So, they are not yet they will be bonded if they are very close, right. But I am asking the intermediate region, in this region what will happen? Yeah. Actually, the correct answer is even though they do not have charges, they will still interact. There will be interaction, but that is non-polar interaction. So, okay. So, this was the electrostatics is a polar interaction, and this is a non-polar interaction. What will happen actually? It depends, but energy will decrease and then increase. So, what is it will something like this kind of plot. Reason is that you may think that they do not have any charges. So, how the energy is decreasing, right? But what happens, even though they do not have any charges, they have electrons. So, two atoms and there are electrons, and so total charge might be 0, but your electrons are present in the molecule. So, they will interact with, those electrons will interact in some way. So, to reduce the energy initially, and if they come very close, then the electrons will repel each other. So, if you initially no interaction, then you are slowly bringing close, electrons will slowly attract each other, energy is decreasing, but when you are bringing the two set of electrons very close to each other, energy will decrease. So, that is why it is decreasing then increasing rapidly, but this is non-polar interaction. This is not electrostatics, separate. So, electrostatics is polar and this is a non-polar, and actually both are present. This is also present, and we need. So, there are two non-bonded terms, one is for electrostatics and one is for this, and this is also called, I will just write here, this is called, okay, let me write here. So, this one is called, you may know this one, van der Waals interaction. Van der Waals you read, I think you read, right, van der Waals interaction, small short form VDW, van der Waals. And what I will do now, I will write the expression for van der Waals interaction here. I will erase this one. Okay. So, van der Waals is something like this. So, E VDW, also there is summation, and Bij Rij 6, and this is I, this is J. And there are two terms in van der Waals, one is 1 over r to the power 12 and other is minus 1 over r to the power 6. Where the minus term is for attractive interaction and the plus term is for repulsive. So, this is another non-bonded terms.